I'm actually going to go over some of this today, just a little bit differently. All right, are there any questions? All right, so far, just during the quick recap we've done, some basic vocabulary for chapter 3. We've talked about position, displacement, velocity, acceleration. What does it mean if they're positive, negative, or zero? So let's get into some of the math part of it. And got a wide variety of math abilities in here. And I've had students in the past who had visibly shaken when they've had to do math. So I don't know, I haven't seen anybody visibly shake yet, but we really haven't done much in the way of math, other than on the labs, but just, I've seen the wide variety. And people get through it. However, just start out with acceleration. All right, so let's first talk about what this actually means. So if acceleration is negative 3 meters per second squared, remember that acceleration is the change in velocity over the change in time. So this means that the velocity is going to change negative 3 meters per second every second. So if we do a quick chart here, time in seconds and velocity in meters per second. 0, 1, 2, 3, 4, 5, 6, 7, 8. Then if it's going 30 meters per second, so we have a car going down the road at 30 meters per second. It has an acceleration of negative 3 meters per second squared. It just means that every second that passes by, the velocity will change by 3 meters per second. So after 1 second, it'll be going 27 meters per second. After another second, keep going.
18, 15, 12, 9, 6.
All right, so after 8 seconds, it'll be going 6 meters per second. So if I told you the initial velocity, so the car is moving on a straight line, if it is initially going positive 30 meters per second, it accelerates uniformly at negative 3 meters per second squared for 8 seconds. How fast is the car going? After the 8 seconds. So we have how far, so we first established it's a straight line problem, so we can get away with doing direction with just a plus or minus. So that's what the straight line says. I put a plus sign in front of the 30 to indicate we are talking about direction. This is a velocity and not just a speed. If I had just left it at 30 meters per second, then it's unknown whether that really is a speed or a velocity, so I put the plus in there just to emphasize it. I could have also said if the initial velocity is 30 meters per second to accomplish the same thing. The uniform acceleration, talking about constant acceleration, and that is going to be critical for this because problems become much more difficult if acceleration is not constant. And in the extreme form, non-constant acceleration typically means calculus is involved. Obviously, not here. So I give you the rate, I give you time, and then the question of how fast is it going, and the answer, 6 meters per second. So let's do it slightly differently. I know that acceleration is equal to the change in velocity over time. So just plugging it in, I know acceleration is -3, and that's equal to my change in velocity over time, which is 8. So depending upon your comfort level, you could just multiply both sides by 8 to solve for the change in velocity, or if you prefer, -3 over 1 is equal to some unknown over 8. I mean, this is the math problem we're working in. So you can cross multiply or multiply both sides by 8, accomplish the same thing. So we end up, what is the change in velocity?
-24.
Okay, I heard that. Finish it off.
Plus, minus,
No, wrong finishing.
7 meters per second.
That's it. Units. All right, so my change in velocity is -24 meters per second. But change, well, change always. One of the few always in the course, always is final minus initial. So this is final velocity minus initial velocity is equal to -24. Well, I know initial, I gave it to you. So VF minus 30 is equal to -24. Add 30 to both sides. And we got to the exact same place. If we hadn't, there would be a mistake somewhere. And it's sort of a double-edged sword. You're on a test, you got time, you're feeling good, you came up with an answer, and you thought, well, let me just try to do this a different way, see if I get the same thing. If you get the same thing, probably should feel good about your answer. If you get something different, now you're in a quandary. How much time are you going to spend trying to figure out where the mistake is? All right, questions to hear? All right, so let's add to this. I will assume that lack of questions means perfect understanding. Excellent. What is the car's displacement? Now, if you noticed on the master set for chapter 3, where we're looking at old tests. If you look at the old tests, I started out making these multiple choice questions, and then at some point I morphed over, I don't know if I have the more recent ones posted in the old test section, but I morphed it over and just leaving sort of open-ended questions instead of multiple choice. The order in which I pose the questions, and there's only about 6 or 7 different questions, is the order in which I would solve it. If you are looking at it and you think, oh, I can do part B, I know how to do that one, and then you do it a different way, that's fine. And then you can go back to do part A. You don't have to do A in order to do B. But let's say that you have to do part A to do part B, but you don't know how to do part A. You can always just make up a number, solve part B, show me you know how to do part B, you get full credit for part B. Part A you get nothing for, but you allowed yourself to show me how to do part B. And then if later on you realize, oh, I know how to do part A now, you don't have to redo everything. You can just go back and say, I assumed this for the rest of it. However, this is what I should have done. find out the correct answer for you. Well, let's go ahead and try to figure this out. What is the car's displacement? Well, let's tackle that. Ooh. Only done it once. I'm not gonna do it again. I know that my average velocity is my displacement divided by time. Well, I know time, it's 8 seconds. But my average velocity, what is my average velocity? Is it 3 meters per second? The acceleration, the change in velocity was negative 3 meters per second squared. The average velocity, how do you find average?
You add them all up and then divide by how many numbers you have.
All right, I got a bunch of numbers right here. I got a whole bunch of velocities right there. You add them all up and divide by the number of numbers, what do you get? Anyone else get the same number? That's a 7. Yes? Okay. Finish it off.
Meters per second.
All right, so we have an average of 18 meters per second. So I now have enough to actually solve this. So I have 18 is equal to my displacement divided by 8. You want units, 8 seconds in meters per second. And again, we're left with the situation of, you can solve it like this, just ignore the units when you're actually doing the math part, or treat it like you're doing some cross multiplication here. So what is the displacement?
Is it 144?
144?
Meters.
Just meters.
Yeah.
All right, so we know how far he's gone. Well, we know what his displacement is, but in this particular case, so he starts out going in the positive direction, and just make that way positive. Doesn't really matter what you make positive. So that way's positive. He's starting at some point in this problem. He goes and he's slowing down the entire time. So he's going at this point 30 meters per second. At this point over here, he's going 6 meters per second. Still traveling in that direction. And he ends up 144 meters on the positive side of wherever he started. Questions to hear? What was the distance he traveled? Do the whole thing. I heard 144 and then stop.
144 meters.
Meters, yeah. All right. So the distance he traveled is 144 meters. Because he doesn't turn around at all, it's just in a straight line. What is his average speed?
18 meters per second.
Yes, all right. So in that particular case, displacement, the magnitude of my displacement and the distance are the same. The magnitude of the average velocity and the average speed are the same. Don't worry, I'll give you a situation where that's not true. I want to talk a little bit about average velocities, unless there are questions. Okay, so when you average up these numbers and you got 18, I assume you added up all 9 of them? Why? By the way, the most common mistake people make is they'll add them all up and divide by 8. Don't forget there is a 9th number here. Why did you add up all 9 of those numbers?
To find the average.
You always add up 9 numbers to find an average? Just because I gave you 9 numbers? You had faith that I gave you everything I did not give you more than you needed? You're not sure? You don't know if you believe in me? Okay.
Is it because that we're seeing that it's accelerated uniformly at -3, the units for 8 seconds, so that's why for the time, is that what we're adding all 9 of them?
And in a sense, but it doesn't have to be all 9 of them. Key thing here, in order for this to work, 1, acceleration has to be constant. If acceleration is not constant, this technique, you can do approximations with it, but this technique doesn't work particularly well if acceleration is not constant. However, oh, and also, if you're gonna do this where you add them up, you need even increments here. That's 1 second, that's 1 second. Each time it's an additional second. But there's nothing special about 1 second. Suppose we just do every 2 seconds. What's the average of those 5 numbers? It's the same thing. So there's nothing special about 1 second increments, just so long again as the increments are the same. So now we have 2 second increments, but there's nothing special about 2 seconds. Why don't we, how about every 4 seconds? What's the average?
18.
Again. Well, there's nothing particularly special about every 4 seconds, so why not every 8 seconds? And the average down. So if acceleration is constant, if you want to find the average velocity, all you really need to do is just add the first and the last one. You don't have to do every single second in between, just the first and the last. So if I change the problem, we'll keep it at that. We'll keep it at a bit too abstract there. Let's now make it 15 seconds. So let's just go through the long way. I know at 8 seconds it's going 6 meters per second. And then 9, 10, 11, 12, 13, 14, 15. So that would be 3, 0, -3, -6, -9, -12, -15. So again, based on what we had written there before, I erased 7 numbers, but we don't need them to find the average velocity. To find the average velocity, all I have to do is just look at the first and the last one, divide by 2. I'm finding the average of those 2 numbers. So what's my average velocity now?
So,
What'd you get?
7.5.
Now, at some point, the vehicle turns around. It starts out going in the positive direction, and then it's going in the negative direction, so it does turn around somewhere. Well, where does it end up? How far is it away from where it started? I know on average it's going 7.5 meters per second for 15 seconds. So what's the final displacement?
Would it be 112.5?
112.5? How'd you get that?
By using velocity average, yeah.
So you put 7.5 there and 15 there?
Yeah.
Yeah. I'm assuming that you multiplied it correctly. Oh, there it is. Let's get rid of just some of this. All right, so my average, we figured out it was 7.5, our average, 7.5. And that's gonna be equal to my displacement divided by time, which is 15 seconds. And so multiply 15 times 7.5, boom, you're there. And you had 112.5? Positive or negative? Yeah, it's positive 7.5, positive 15. It better be positive. Or the math people have been lying to us all this time. Wouldn't put it past them.